questions 11 through 20 on the 2006 grade 12 AMC 12A. Which of the following describes the graph of the equation x plus y all squared is equal to x squared plus y squared? X plus y all squared is equal to x squared plus y squared. Multiply this out. You got x squared plus 2xy plus y squared is equal to x squared plus y squared. The x squareds and the y squareds from both sides cancel, and that leaves you with just 2xy is equal to 0. And there's a lot of ways of interpreting this. I think the simplest way is to look at this and say, well, it's either x equals 0 or y equals 0. Correct? And if that is the case, and you draw yourself a little graph here, x equals 0 is what? Well, x equals 0 is basically the y-axis from top to bottom right there. That is x equals 0. Y can be anything, but x is always 0. And then y equals 0, this guy, well, that is the x-axis. X can be anything, but y is always 0. So basically, this means the x-axis and the y-axis, and both of those are lines. So therefore, the answer to this question is 2 lines. So number 11 is C. A number of linked rings, each with 1 centimeter thick, are hanging on a peg. The top ring has an outside diameter of 20 centimeters. The outside diameter of each of the other rings is 1 centimeter less than that of the ring above it. The bottom ring has an outside diameter of 3 centimeters. What is the distance in centimeters from top of the top ring to the bottom of the bottom ring? Okay, so the first thing, right, they give you this 20. So that helps us. That's one distance. Then we have to, in a systematic way, calculate all the other distances. So like that, right? So let's talk about this. The distance from here to here, like that, that is going to be just a little bit different than the first one. The first one is the full distance from top to bottom, and that's 20. But when you get to the next one, first and foremost, you have to understand that it is 1 centimeter less in terms of its diameter from top to bottom. So from top to bottom, instead of 20, it'll be 19, correct? So that distance is 19. But then you also have to subtract that distance in order to get this distance. And what is this distance? Well, it's 2, because each of those rings are 1 centimeter thick. So that's 2, so therefore this is 17. All right? In a very similar way, I'll use a different color. Top to bottom, from there to there for the next ring, is 18, 1 centimeter less. But if we want this distance, we have to subtract from it that distance, which is 2. So this is 16. And if you continue this, you'll see it'll be 15, 14, all the way down to the very last one, which will give you 1. So when you add all these distances up to get the total from top to bottom, it's 1 plus 2 plus 3, all the way till 16 plus 17, and don't forget about that final 20. Now the sum of consecutive numbers, you know the formula, n times n plus 1 over 2, correct? So this is going to be 17 times 18 divided by 2 plus 20. And 17 times 9, which is 153, plus 20, and that is 173. So number 12, the answer is B. The vertices of a 3, 4, 5 right triangle are the centers of 3 mutually externally tangent circles as shown. What is the sum of the areas of these circles? So I'll blow this up a little bit, and I think that should be good enough. Okay, so let's start labeling this any way you want, really. I'm just going to use letters. This I'll call A. Anything really doesn't really matter. I'm just debating what letters to use. Do you use R or I'll just call them Y and X and Z, I guess. So those, of course, represent the radii. Correct? Y represents the radius of B, circle B. X represents the radius of circle A. And Z represents the radius of circle C. Now, in this question, we can clearly see that X plus Y is equal to 3. X plus Z is equal to 4. And Y plus Z is equal to 5. So we've got 3 equations, 3 variables we can solve for X, Y, and Z. Correct? So in any way you want, let's see here. This one will give me Y is equal to 3 minus X. And this one will give me Z is equal to 4 minus X. And then I can sub both of those into here. So 3 minus X plus Z, 4 minus X, is equal to 5. And therefore this looks like 7 minus 2X is equal to 5. And therefore 2 is equal to 2X. And therefore X is equal to 1. So going back here, this looks like Y is 2 and Z is 3. So there you go. We've got values for X, Y, and Z. Now we have to figure out the area of these circles. Circle B is pi r squared. Pi is Y. Circle A is pi r squared, of course. Again, in this case, our r is X. And circle C, pi r squared, our radius is Z. So there you go. And we have values for X, Y, and Z. For Y, it is 2, so that's 2 squared. For X, it is 1 squared. And for Z, it is 3, so 3 squared. So this becomes 4 pi plus 9 pi, and that is 14 pi. So going back, the answer choices, 13 is E. Two farmers agree that pigs are worth $300 and goats are worth $210. When one farmer owes the other money, he pays the debt in pigs or goats with change received in the form of goats or pigs as necessary. For example, a $390 debt could be paid with 2 pigs with 1 goat received in change. What is the amount of the smallest possible debt that can be resolved in this way? So our debt, I'll call it D, is equal to this equation, $300 times the number of pigs minus $210 times the number of goats. That's our equation. Now we have to figure out what's the smallest possible value for D. Okay, well, going through these answer choices, the first one, 5, is not possible because if you subtract any multiple of 210 from any multiple of 300, the answer will always be some multiple of 10, right? You're never going to get a 5. So that's out. The second choice, 10, okay, that seems promising. You think, okay, I think that can work. But when you fiddle around with this, you will see it doesn't work, no matter what you plug in. And that's what this is. This is a fiddle around question, because this is the only piece of information you've been given. And the only other thing you know in this question is that P and G are integers. So now, when you get to 30, very quickly, the good news is you can figure out a scenario for this. By inspection, when P is 5 and when G is 7, this will work. It'll give you 300 times 5 minus 210 times 7, which is 1,500 minus 1,470, and that is indeed $30. So a debt of 30 can be resolved using this system of pigs and goats. So number 14, the answer is C. Suppose cos x equals 0 and cos of x plus z is equal to half. What is the smallest possible positive value of z? All right, this is another plug and play time drain question, because you just have to solve this by plugging in different values and fiddling around. All right, so here we go. So cos of x equals 0, right? So that means that x is equal to any number like 90 or 270, ... right? Because a lot of these will give you 0, minus 270, and so on. I'll just put 4 in. And then if cos of x plus z is equal to a half, in a very similar way, x plus z can also have multiple values, right? It can be minus 60, it can be 60, and probably several other infinite numbers of values. So we have to find the smallest possible positive value of z. All right, I'm just going to stick with these two. I think we should be able to find the answer with just either 60 or negative 60. And for x, let's see here. How far do I want to go? I'll just use all 4. I don't think it'll take that long. Okay, so here we go. We know that x plus z is equal to, first let's do 60, negative 60, this guy right here. And then I'll do it for 60. So we have to plug in these values for x and see what we get for z. Okay, that can be done fairly quickly. So for minus 270 plus z, that will give me z is equal to 210. When x is minus 90, like that, equals minus 60, z will be 30. Next one, we've got x equal to positive 90 is minus 60, and z will therefore be minus 150. And then finally, rounding this out, we got one value of 270 for x, and this will give you z is equal to minus 330. Okay, so of these, the smallest positive value of the 4 that I just figured out, smallest positive value is 30. All right, let's quickly do this guy here now, positive 60, and let's see if we get anything smaller in terms of a positive value. Okay, so we got 270 again, minus 270, plus z this time is positive 60, and therefore z is 330. Then minus 90 plus z is 60, and z is 150. Then we've got positive 90 plus z is 60, and z is minus 30. And then finally, 270 plus z is equal to 60, and z is minus 210. All right, anything that beats what we found in terms of smaller positive value of z? And the answer is no. Our positive values are 150 and 330. All right, so it was z equal to 30, and that is pi over 6. So that's choice A. 16. Circles with the centers A and B have radii 3 and 8 respectively. A common internal tangent intersects the circles at C and D respectively. Lines A, B, and CD intersect at C, and AE is 5. What is CD? All right, so the first thing I'd like to do is draw in some lines. The first line is A to C, like that. And then the next line is D to B, like that. And these are tangents, so this is going to be right angle here, and this is going to be a right angle there. Okay? So far, so good. Now, let's see here. They tell us in the question that this first circle has a radius of 3, and the second circle has a radius of 8. So those I will label. And then they also tell me that A to E is 5. From here to here is 5. So that means this distance is 2 from there to there. Now in this triangle right here, you can quickly figure out that CE must be 4. Why? Because 3 squared plus 4 squared is equal to 5 squared, right? Probably the most common Pythagorean relationship. Okay, we've got some pretty good progress so far. Anything else? Well, I immediately noticed that these are going to be triangles that are very similar, these two. And the reason is because they share one angle already, that's the right angle, and then these two angles are opposite, so they're equal, opposite angles. And then therefore this angle in here is going to be 90 minus theta. All right, so those are indeed similar triangles. So therefore, we can use similar triangles. The ratio of the sides will be the same. DE, this guy right here, which is the theta right side, will be the same as that in terms of the ratio over 4 equals, I'll just do the radii. This is the first one, the 90 minus theta right side. And on the other triangle, the 90 minus theta right side is a 3. So there you go. That's my relationship. So 3 times DE is equal to 32. And therefore DE is 32 over 3. And they want you to figure out CD, the whole distance from there to there. Well, from C to E is 4. And then from E to D, we just figured out was 32 over 3. So CD is equal to CE plus ED, like that. CE is 4, and then 32 over 3 is ED. Add the fraction, you got 12 plus 32, which is 44 over 3. And 44 over 3 for number 16 gives you choice B. Square ABCD has side length S, and a circle centered at E has radius R, and R and S are both irrational. The circle passes through D, and D lies on BE. Point F lies on the circle on the same side of BE as A. Segment AF is tangent to the circle, and AF is equal to the square root of 9 plus 5 root 2. What is R divided by S? So in this diagram, I'm going to draw a couple lines here that hopefully will help us. Hopefully. So the first line is between F and E, like that. The second one is from B all the way to E, and it will pass through D, as they stated in the question. And then I think the last one will be from A to E. I think that should be good enough. And then this, because F is a tangent, that's a right angle right there. And that should be sufficient. If it's not, we can always add things later. All right, let's start labeling as much as we can. AF, they tell you, is 9 plus 5 root 2 all under the square root sign. F to E is R, which is the radius. E to D is the radius. And they also tell you that the square has side S, like that. And I think that's it in terms of labeling. Okay, so the first thing I want to do is calculate some sort of a value for B to D, like that. And I can do that using this triangle BDC. So in that triangle, S squared plus S squared is equal to BD squared. And therefore BD is 2S squared under the square root sign, and therefore BD is root 2S. So I'll write that in there, root 2S, the distance from B to D. Okay, now where do I go from here? Well, I think this relationship is going to help us, this right triangle, so let's use that. Hypotenuse is AE in this case, and that equals R squared plus 9 plus 5 root 2 under the square root sign, all squared. And that just becomes R squared plus 9 plus 5 root 2, like that. And that is AE squared. All right, so far so good. Now, AE, I can also figure out in another relationship using this triangle right here. Now, at first, it may not seem that obvious because there's no right triangle, so we're not going to use Pythagoras. So you might say, well, what do I use then? Well, you would use the law of cosines. Law of cosines. And you say, well, I need an angle for law of cosines. I don't have any angles. Well, you can make one because this is 45 degrees, correct? It's just a 90-degree angle chopped in half because of that diagonal. So here we go. I use AE again. AE squared is equal to AB squared plus BE squared minus 2AB times BE cos of 45. So there you go. Okay, so we've done most of the work here. The good news is that we got two relationships for AE. We got AE equal to that and that. So because we have two, we set them equal to each other. So I'll do that down here. R squared plus 9 plus 5 root 2 is equal to AB squared. This whole thing right here. But instead of writing it all out, I'll just put in the values. AB is S. Then AB squared is basically the distance from here to here, but BE squared is the distance from all the way to there. So that's root 2S plus R, all squared. Okay, just make sure you don't make any mistakes there. Then we got our S and BE again, so root 2S plus R times the cos of 45, which is root 2 over 2. All right, so this is our equation that hopefully will help us solve for R over S. That is what we have to figure out. Okay, so here we go. R squared plus 9 plus 5 root 2. This is S squared. Multiplying this all out, you get, let's see, 2S squared plus 2 root 2SR plus R squared. And then this is going to be minus 2S squared minus root 2SR. Okay? Now a whole bunch of things will cancel, I hope. This cancels. Yeah, anything else cancels here? Oh yeah, this guy. That cancels with that. So we are just left with 9 plus 5 root 2 is equal to S squared plus root 2 SR. Okay? Now it's a little unconventional the way we have to approach this now. We just have to match terms. So S squared is equal to 9. I know they're not really used to doing that, but that's what we have to do here. So that means S is 3. And then this guy is that guy. So 5 root 2 is equal to root 2 SR. Well, S we just figured out was 3. So it becomes 5 root 2 is equal to root 2 times 3R. Root 2's cancel. And then you just bring the 3 over. And that becomes R. So then finally our R over S would be 5 over 3 over 3. Invert and multiply. And you'll get 5 over 9. And that is your answer. So this question, which was number 17, the answer is 5 over 9, and that is choice B. The function f has the property that for each real number x in its domain, 1 over x is also in its domain, and f at x plus f at 1 over x equals x. What is the largest set of real numbers that can be in the domain of f? F at x plus f at 1 over x is equal to x. Now, instead of x, I want to put 1 over x because that is also in the domain. So I will put 1 over x instead of x. And here it'll be 1 over x. And therefore that must be, by our definition, equal to 1 over x. Correct? Because if I substitute x here, it's equal to x. So if I substitute 1 over x, it's got to equal 1 over x. Just by the definition right there of that function. So let's see what we get here. We get 1 over x, and then this invert and multiply 1 over 1 times x over 1. And this looks like 1 over x, and this is just f at x. Okay? Well, this part here is exactly the same as that part there. It's just reverse order, but the sum is the same. So if those two are the same, then that means this and this are the same. So that basically means that x is equal to 1 over x. That's the only way this can work. If that is the case, cross multiply and you get x squared is equal to 1. Take the square root of both sides and you get x is equal to plus or minus 1. Those are the only two values for x that will make this hold true, this property. And therefore, x equals plus or minus 1 are the only two values, and for number 18, that would be choice E. Circles with centers 2, 4, and 14, 9 have radii 4 and 9 respectively. The equation of a common external tangent to the circles can be written in the form y equals mx plus b with m greater than 0. What is b? So I'm going to label a few things here. The first thing is I want to extend this line to the x-axis like that. And the next line I want to draw is between the two centers. And I will continue that line all the way to the x-axis like that. Okay? Then I will connect the center of the large circle to its tangent point like that. And I'll also draw the line down to the base, which is the x-axis. And I can do the same for the small circle like this. Then finally I'll draw two lines that are parallel to the x-axis first like that, and another line that's parallel to that tangent line. And that should be sufficient for our question. Start labeling some of these right angles. That's the first right angle. This is the second right angle, right? Because this is tangent, so that is a right angle. And this is a tangent, and that is a right angle. And since those two lines are parallel, they also make right angles. Now I will start labeling some of the distances. We know that the small circle has a radius of 4. So from here to here is 4. And if that's the case, and this line is parallel to the tangent line, the distance from here to here will also be 4. And the radius of the large circle is 9, so therefore the distance from here to here will be 5. And in a very similar way, this is 4, this distance is 4, and this distance is 5. This distance right here we can get easily from the fact that we know the x-coordinates are 14 and 2. So 14 minus 2, which is 12, is that distance right there. So this line right here is what I want to concentrate on first. I will call that L1. All right? And L1, I want to know its slope. Well, the slope of any line we can figure out easily with rise over run, as I'm sure you know. And the rise in this case we can get easily through this triangle, and we can also get the run. The rise is 5 and the run is 12. So the slope of that line L1 is 5 over 12. And you could easily calculate that slope using these 2 points as well. Either way it would work. Now that line L1, because it is a line, it has the form y equals mx plus b, as all lines do. And since I have 2 points, I can substitute those 2 points in to figure out what is the exact equation of this line. So let's use the first point, 14, 9. That would give me 9 is equal to 14m plus b. And if I substitute the second point, that would give me 4 is equal to 2m plus b. Okay? Now we already know the slope is 5 over 12. So m is 5 over 12. So I can put 5 over 12 into either of these. So if I put 2 times 5 over 12, this will allow me to calculate for b. And this looks like 4 minus 5 over 6 is b. And therefore b is equal to 19 over 6. So this equation is y is equal to 5 over 12x plus 19 over 6. The equation of line L1, which is right there, this line. All right, so why was that important? Well, that allows me to figure out this point right here, that point. And that is going to help us with that line eventually. So how do I figure out that point? Well, what is that point? Essentially, it is where it crosses the x-axis. So when y is equal to 0. So when y is equal to 0, we set that in this equation, and this will allow us to get the x value. So if we do the math here, we got minus 19 over 6 is equal to 5 over 12x. So x looks like minus 19 times 2 over 5. And that is equal to minus 38 over 5. So that means this point is minus 38 over 5 and 0. Okay, so at this point, now we can finally concentrate on this line right here. But before we do that, I'd like to revisit this triangle right here and explain the concept that will help us figure out this important line, its slope. In this triangle right here, if you label this angle here theta, the tangent of that, in our case, is 5 over 12. And what's interesting is that represents also the slope, which is denoted by m. And if you were to look at this diagram, if that is theta, this is also theta right here. Okay? And this angle, theta, is essentially half of that angle right there. So that is 2 theta. Because this diagram is symmetric about this line. Everything on this side is exactly the same as that side. So therefore, that line from here to here that we denoted L1 cuts that big angle exactly in half. So it cuts 2 theta into half, making it theta. So now I want to look at 2 theta. And what is the reason I want to look at 2 theta? Well, because think about it. If tan of theta represents the slope of this line, tan of 2 theta will represent the slope of that line in a very similar way. So the tan of 2 theta I need to calculate without the use of a calculator, because calculators are not allowed on the US math contests. So I have to use my 2 tan theta style of calculation. 1 over tan of theta squared. This is the equation for tan 2 theta. So that would mean 2 times tan of theta, which is 5 over 12, all over 1 minus 5 over 12, all squared. And this gives me a value of 5 over 6 over 1 minus 25 over 144. And this is 5 over 6 over 119 over 144. And that is 5 over 6 invert multiply 144 over 119. And that reduces to 120 over 119. So going back to our diagram, what that basically means is that this line right here, from here to here, that line has a slope that we just calculated. And that slope was 120 over 119. So we are interested in y equals mx plus b. We want to know in particular the value of b. Okay, we already found the value of m, 120 over 19, 119. And now we can figure out b. But how can we figure out b? Well, the good news is we have a point on that line. That point was on both lines. It was on L1, and it's also now on this line, which I can call L2. So substitute that point into here, and we will be able to calculate for b. So we've got 0 for y is equal to 120 over 119. X is minus 38 over 5, like that, and plus b. So put everything on the other side, you get positive 120, positive 38 over 119 times 5. Now I've got to do a little bit of reducing to lowest terms. This looks like 24 times 38 over 119. And if you multiply that out, you get 912 over 119. So that is the value for b, and that is what they're looking for in this question. What is b? And therefore the answer for number 19 is E. A bug starts at one vertex of a cube and moves along the edges of a cube according to the following rule. At each vertex, the bug will choose to travel along one of the 3 edges emanating from that vertex. Each edge has equal probability of being chosen, and all choices are independent. What is the probability that after 7 moves, the bug will have visited every vertex exactly once? So let's draw a little diagram for ourselves. Let's label these vertices A, B, C, D, and I'll call them E, F, G, H, like that. And then let's now discuss this question. Let's make A our starting point. So this bug starts at A. From A, it can go to any of the 3 edges, along the 3 edges, to the next vertice. So its choices would be vertice B, or vertice D, or vertice H, correct? Vertex, whichever way you want to pronounce it. So now, once you're there, where do we go from there? So let's say he is starting at A. He's got 3 choices, correct? B, D, or H. Now at this point, we'll choose his next point. We've got to choose somewhere. So let's just choose B. He goes next to B, let's say. From B, where can he go? Well, he can't go back to A because he can only visit the vertex, each vertex exactly once. So from B, he can only go to either C or G. And therefore, that gives him 2 choices. Let's choose C. Let's say he goes to C next. Okay, now he's at C. Now from C, where can he go? Well, he can't go back to B, but he can only go to D or F. So he goes to D or he goes to F. Now at this point, our choices are very limited. For example, if he goes to F, from that point, he can only go in one path. And that path is G, H, E, D. And that's it. That's the only way you can visit all the vertex exactly once. If from C, he decides to go to D, then from there, he has only two ways to go. He can either go E, F, G, H, like that, or he can go E, H, G, F. And that's the only possible way he can go to each vertex exactly once. So from C, we have three choices, these three. 1, 2, 3. These paths, I guess. So B gave us 2, A gave us 3. And no matter which combination you choose, this will be the end result. So 3 times 2 times 3, that is the total possible ways that you can get to satisfy the requirements of the question. So 3 times 2 times 3 is 18. But this is a probability question. So they want you to figure out usually a fraction, right? Something over something. Well, the numerator we just figured out was 18. But what's the denominator? Well, the denominator in any probability question will be the total number of ways. The total number of ways regardless of any condition. Well, we have 1, 2, 3, 4, 5, 6, 7. 7 moves, right? And for each of these 7 moves, you have, without any conditions, 3 possible choices. 3 places that you can go. From A, for example, you have 3 vertex that you can go to. You can go to either B, D, or H. If you go to D, you can go to either A, C, or E, right? Regardless of the conditions, if you're just looking at total number of choices. So 3 times 3 all the way. So this is essentially 3 to the power of 7. So that is your probability. Now, of course, we've got to lower this to some sort of lowest terms. So let's see here, 18 over 3 to the power of 7, which is 2187. And if I divide top and bottom by 9, I'll get 2 over 243. So number 20, the answer is C.